Well, once again, welcome to my YouTube channel, and it's called Pearson and Excel International Maths by Mr. Kamotho. And today I want us to explain topic number 7 and example 3 of this book, Pure Mathematics 3, and we are on page 149. And we are told that up there, integrating the function ax plus b, that's where we are. If you know the integral of a function fx, you can integrate a function of the form fax plus b using the reverse of the chain rule for differentiation. If you know the function, the differential, if you know the integral of a certain function, then you can integrate a function of this form using the reverse of the chain rule, which we learned in the last topic. And I want us to just introduce topic, or rather, example 3, part A. And you're supposed to integrate the cosine of bracket 2x plus 3 with respect to x. And we know very well that integrating the cosine of x, it gives sine of x. So if we know we are going to get the sine of x, and I hope we know what to do. When we differentiate something, it gives us a differential. When we integrate a function, let's dy dx of fx, it gives us function of the derivative of the function. This is differentiation. If we integrate the derivative of the function, it gives us the fx, which is sometimes called y. It is important to note that. So in this case, we might be integrating a differential, so this must be a differential, so that we can get to the function. And if we are integrating a differential to get back to the function, and we know the integration of cos x is sine x, so we can already tell that the function was supposed to be sine 2x plus 3, because the integral of the cosine of anything is the sine of that whatever was there. So assuming this bracket has x, the cosine of x is equals to the sine of the same x. So such that if we differentiate now this, if we differentiate this sine 2x plus 3, it should be able to get us back to what we have here. But because we are not very confident about it, and the reason why we are not very confident is because the bracket does not just have x, it has x with some other terms. So let us see what will happen if we differentiated now the sine of 2x plus 3 to see if it can give us the cosine 2x plus 3. So dy dx is the cosine of 2x plus 3, of course, times 2. Why times 2? Because the chain rules demands that we get the differential of the entire statement multiplied by the differential of the internal term that is having x. So this entirely is going to give us 2 cos 2x plus 3. But look what we have. We have more than we bargained for. That means our original, we have double of what we had originally. What does this tell us? That our y was not specifically this. And since we have double of what we wanted, we must have now differentiated half of what we differentiated. So our y is going to be a half of sine 2x plus 3, such that in this case now our dy dx is going to be a half sine 2x plus cosine 2x plus 3 times 2, such that these 2 and these 2 will cancel out and we'll be left with the cosine of 2x plus 3. So exactly, so our y is supposed to be a half sine 2x plus 3, and that gives us now the integral of the cosine of 2x plus 3. And I want to repeat that step before I go further to part B and part C and say this. If we are expected to integrate the cosine of 2x plus 3, of course we are expecting something to do with sine. If the whole of this bracket is reading x, then the integral of cos x should give us sine x. We know if we have y, the differential of a certain function, fx, you can also call it y, is actually the differential of the same function, which can also be y prime. If we integrate this, if we integrate now, the f prime x should give us the original function, or rather the y. That means what? If we happen to integrate the cosine of 2x plus 3, it should give us sine something. And that means if we differentiate sine, whatever it is, then we should be able to get back here. This is now a differential of something, of a certain function y. So let us assume y is sine 2x plus 3, such that dy dx is going to be cosine 2x plus 3, of course times 2, because of the chain rule, application of the chain rule, which gives us now 2 cosine 2x plus 3. If this is now the differential of what we supposed our y to be, you can already see it's giving us twice of what we need to integrate, and therefore whatever we differentiated to give us this must be divided by 2, so that when we differentiate it, it should give us now what we have. Look at it this way. If we differentiated sine 2x plus 3 to give us 2 cosine 2x plus 3, then we must be prepared to differentiate a half sine 2x plus 3, which we have done here, to give us a half cosine 2x plus 3 times 2, and this 2 and this 2 cancel out to give us the cosine of 2x plus 3. And this is exactly what we have. So therefore, if this is a differential, then the function was, if the differentiating cosine 2x, or rather integrating cosine 2x plus 3 dx, if this is a differential of something, then the function itself would have been a half sine 2x plus 3. And that is just like it. Obviously, because it is limitless, we have to add the constant, and this is our answer to that one. In this particular topic, please be keen. In this particular topic, just be keen. And we have said that if this is now the integral, if this is if you're supposed to integrate cosine 2x plus 3, then that means we should be getting back to the function, which is the sine 2x plus 3, and that is it. We will be getting to part B of the same, but this is it. Always try to find out what was the function before this derivative came here, because this is a derivative. Because the moment we integrate a derivative, it is taking us back to the function. All right?